Here is another complex exponential example with different period. It is repeated after every 8 samples. From the definition of period, we understand that x of small n plus n equals to x of n. If this relation satisfied, a period is referred to as capital N. For this particular function, we have x of n plus 8 equals x of n for all values of n. Hence, we can infer the period n equals to 8. Since period n equals to 8, we can refer that the fundamental frequency of omega 0 equals to 2 pi over n equals to 2 pi over 8 equals to pi over 4. From the definition of this signal, we could get coefficient ck and the range of k is from 0 to 7. So now, how to get this ck? We perform inner product on Cn and e to the power of jk omega 0 n, where omega 0 is the fundamental frequency that we calculated here, which is pi over 4, and x of n equals to e to the power of j pi over 4n. The expression for the inner product xn and e to the power of jk omega n is therefore ck equals to summation of e to the power of j pi over 4n dot e to the power of negative j pi over 4n equals to summation of e to the power of j pi over 4 times n times 1 minus k, where n is from 0 to 7, where k is from 0 to 7. So we need to note that we replace the value of n from 0 to 7, that would be 1 period. So we can calculate ck accordingly. For k equals to 1, we have ck equals to 8 times e to the power of j pi over 4 n times 1 minus 1 equals to 8 to the power of 8 times e to the power of 0 equals to 8. So for ck not equals to 1, summation of e to the power of j pi over 4 n times 1 minus k equals to summation of e to the power of j pi m, where we denote m equals to n times 1 minus k. It's an integer, and the summation of all roots of unit equals to 0. Hence, ck, when k not equals to 0, equals to 1, equals to 0. Now we have ck equals to 0 for all values of k except ck equals to 8. We can plot the value of coefficient ck against k in the following manner. This graph can also be interpreted as discrete time coefficient of the signal for varied values of omega, with impulse 8 at omega equals to pi over 4, and the values of omega at the component frequency and component frequency are 0, omega 0, 2 omega 0, 3 omega 0, 4 omega 0, 5 omega 0, 8 omega 0, 7 omega 0, where omega 0 is calculated as fundamental frequency pi over 2 in the first slide.